All right, I believe this is the last lesson of, or the last part of section 3.4 that I'm going to teach. What's the work, or what's the, what do you call it, lesson plan thing? I think I'm going to give you some worksheets tomorrow. Is that correct? Okay. So it's basically over everything from section 3.4. Okay. So what was the first thing? Let's review quickly. What was the first thing we did on 3.4? Distance formula. Then we did the midpoint formula. Then we just finished what? The slope. Okay. So we're going to have worksheets on all three of those just to kind of reinforce it a little bit. And because that's really important. I mean, it really is, especially when you get into Algebra 2. Do you remember doing this in Algebra 1? Like distance form. Did you do distance formula? You did. You just remember slope. Okay. In Algebra 2, you'll definitely do all three of those. All right. So when you get to Algebra 2, whoever your Algebra 2 teacher is, then you tell them, say, "Thanks, Mr. Hamrick. I know how to do all this stuff." All right. Maybe you will. Maybe you won't. All right. Let's talk about these two words right here. Parallel. We've already talked about the word parallel, haven't we? What does that mean to be parallel? Two lines are parallel. They do what? They never touch each other, right? They're in the same plane. Oops. Don't want that. I'm going to copy that, paste that. There we go. They're in the same plane and they never intersect, okay? They never touch each other. That's fine. You can say that. I know what you mean, all right? But they never intersect each other. We had a little symbol for parallel lines. Remember that? There's a little arrow. Oh, yeah. I showed you the arrow thing, didn't I? Did I show you this? Okay, that's what I thought. All right. So that means what's true about these two lines right here? Call it L and M. All right, now we can do what you were going to say. Now, if you wanted to write that these lines are parallel, what would you write? You write line L is what? It's not equal to. Parallel to. Whoops, that's a weird parallel. Should be the same length. All right. So that means what? That means line L is what? Parallel to line M. Everybody got it? They don't intersect each other and all that. But what are we talking about in this last little section yesterday? We talked about the what of the line? The slope of the line. So let's talk about the slopes, right? Parallel slopes. That's what we're going to talk about. So if these two lines are parallel to each other, just a wild guess, okay? You don't have to prove it. You don't have to give any background information or anything. Just what is a wild guess about the slopes of both of these lines? They're going to be exactly the same. That's right. Okay, because they slant the same way, right? They have the same, what's the word we used yesterday? S. The same what? A mountain is what? When you go up a mountain, it's steep, right? It has the same steepness, okay? So this has the exact same steepness as this has. So the parallel lines, if lines are parallel, what's true about their slopes? They are what? The same, okay? And so let's write that down. So parallel lines, or parallel, yeah. Parallel lines have equal slopes. All right? That's a postulate. All right? What do we know about a postulate? Can we prove it? I talked about proving it. Can we prove a postulate? No. Not a postulate. What can we prove? A theorem. Okay, but a postulate is just accepted without fact. I nerded out a little bit last night, and this video came up on my YouTube feed. I thought, that looks interesting. And it was kind of interesting for a while. Then it went way over my head. But they were talking about pi, right? You've heard about pi. And they were talking about how they got pi. Where did it come from? Who are the first people that kind of figured out what pi is? And then they started talking about slopes, and they started talking about postulates and theorems. And in that video, he was saying a postulate is accepted without any proof. You don't have to prove it. And then right after that, he said a theorem is something that needs to be proven. I'm like, I say that all the time. And here it is in this video. All right. And that video got millions of hits and stuff. So anyway, so I'm not the only one that says this stuff. Right. So postulate is it's just accepted as fact. All right. Everybody good? So lines that are parallel, they have the same slope. So what if the slope of line L, I'm going to put little L right there. See that M and then a little tiny L underneath of there? That's the slope of line L. Let's say that's equal to, 2 over 1. So what's the slope of line M going to be? The slope of line M. So if the slope of line L is 2 over 1, and they're parallel to each other, what's the slope of line M? 2 over 1, right. Okay, not a trick question. Really simple, really easy. Everybody got that? Okay. Let me see something. Yep. All right. So we're not just talking about parallel lines today. What's the other one we're going to talk about? Perpendicular, right. So let's talk about, and we're going to talk about not just the lines, but the perpendicular what? Slopes, the slopes of perpendicular lines. So let's draw a line that kind of looks perpendicular. With my program, I can make sure that it is perpendicular. Well, it doesn't look vertical. Let's try this again. Boom, boom. Wait a minute. Does that look up and down? I think it's still slanted a little bit. Anyway, there we go. Let's raise that up just a tad so it hits. I could make this thing go all the way through, but I'm going to stop it right there, okay? So I got 2 lines right here, line segments right here, and if I put a little box, what does that little box mean? 90 degrees. It's 90 degrees, okay? It's a right angle. If I wanted to continue that all the way through, if I wanted to go all the way through, I could do that. We'll just do that, okay? So these are perpendicular. Now, and I could do this. Watch. I could go like that. Are they still perpendicular? Yep. Yeah, they're still perpendicular. Just because I turned it, rotated a little bit, they still make a right angle with each other, and they're still perpendicular. So let's talk about these 2 lines. Let's call this A and B. All right, just make it easy. So that's line A. That's line B. I use lowercase letters. Remember that? Lowercase letters to name a line. Yes? All right. So let's first of all talk about the positive and negative. Everybody's up here. Dylan, this is brand new for you. There's no way you should not be paying attention. No. I didn't ask. Just turn around and face it front. See, we don't act that way in this class. In the other class, but not in this class. Okay. Shh. So let's take a look. These 2. Let's talk about the positive, negative, the direction of these lines. What about, let's do B first. B is what? Positive or negative? The slope. Why is it positive? Because from left to right, it's going what? It's going up. Okay? It's going up. What about A? Line A, it's going down, right? From left to right, you would be going down the hill. Agreed? Okay. So when 2 lines are perpendicular, okay, one line is going to be what? Positive, and the other line is going to be negative. Okay? Everybody with me on that? Now, here's one thing that you probably would not see. I'm not going to go, this is a postulate anyway, so there's no proof for it. But I'm just going to tell you. So let's say the slope of this line, remember we did those parallel lines, we said they were, what would we say, it was 2 or something like that? Is that what I said it was? I'll just make something up. Let's say the slope of line B is 5 over 2. And it's positive. Okay? Everybody see that? Yeah. Now, is line A as steep as line B is? Does it have the same steepness? No. Line B looks a lot steeper, doesn't it, than line A? All right, so they don't have the same steepness, but there is a relationship between the slopes of the 2 lines. I'm not going to make you guess, but they're an inverse relationship. You ever hear that word inverse? Probably did in Algebra 1, didn't you? Reciprocal? You've heard reciprocal, right? Well, inverse basically and reciprocal basically mean the same thing. So the slope of line A, watch this, is equal to, now, if B is positive, what's A going to be? Negative. And then we're going to take the inverse or the reciprocal. What's the reciprocal of 5 over 2? It's 2/5, 2 over 5. So that's what's true about 2 lines that are perpendicular. That's what's true about the slopes of 2 lines that are perpendicular to each other. Okay? The signs are different. All right? And let's do this. Let's not use A over B. Let's use P over Q or something like that. So if one slope is this, what's the slope of a line that's perpendicular to this one? Well, if this one's positive, this one's going to be what? Negative. If this one's P over Q, what's this one going to be? Q over P. Everybody see that? They don't have the same slopes. They're perpendicular. All right? So if two lines are perpendicular, then the slopes, here's a word that I use a lot. The slopes, let's write it down like this. The slopes are negative. And we'll use that word reciprocal. Is that all right? We say they're negative reciprocals of each other. All right? So here's, and this isn't hard. It's pretty simple, actually. So what if the slope of line A, forget the A and B up here. This is just completely different, okay? Say the slope of line A is equal to negative 2/3. And if A and B are perpendicular to each other, what's the slope of line B going to be? I'll put a perpendicular symbol here. What's the slope of line B going to be? Say it again. Positive 3/2. Very good. It's that easy, isn't it? Okay? I just take the opposite sign. All right? So if one's negative, the other one's going to be positive. And if this slope is 2/3, the slope of the other line is just going to be the reciprocal of it. We just flip it. Now, here's something else to tell you. If you have a slope of one line and it's perpendicular, this is all perpendicular, and it's perpendicular to another line, what happens if I take the two slopes and multiply them together? All right, like these right here. Take that and that, multiply them together. What do you get? Give me the number. I want the number. Is it 1? It's a negative times a positive. So what's a negative times a positive? It's negative. And then if I go 2/5, let's just write it down so you see it. Negative 2/5 times what? Positive 5/2. What does that equal? Yeah, don't even do that though. Look, the 5's cancel, the 2's cancel. What am I left with? 1. Everything goes one time, right? So what is the answer? Negative 1. I mean, you could go negative 10/10. That's fine. You still get negative 1, don't you? All right. What about these two right here, this one and this one? What if I multiply those two slopes together? I still get what? Negative 1, all right, when I multiply them together. So if I took the slope of A, multiplied it by the slope of B, I'll get negative 1. Do I only get negative 1 because I picked those certain numbers? No, anything. Like right here, what if I multiplied those together? Watch, what if I took P over Q, multiplied it by negative Q over P? What's that going to give you? Well, those cancel out to be a 1. These cancel out to be a 1, but I still got a negative, so what is it? It's negative 1. So, anytime you have perpendicular lines, okay, anytime you have perpendicular lines, the slopes, if I multiply them together, are going to equal what? Come on, we've done it 3 times now. I've started a pattern. It's negative 1. That's right. Okay, so if you have two lines that are perpendicular to each other, if I multiply their slopes, you get negative 1. Now, there is one situation where you're not going to have that happen, and that was the first situation that I drew. If, oops, okay, that and that. What's the slope of a horizontal line? We talked about this the other day. It's 0. So the slope of that line is 0, correct? What did we say the slope? Did the big old story about me hanging upside down? What's the slope of this? It's no slope, or it's undefined, isn't it? Everybody follow me on that? So, like if I wanted to go from here to here and I wanted to find the slope, it's rise over run, correct? So what would I do? I'd rise a certain direction, and then how far would I run? 0. Do you see that? Okay. So if I mean, you kind of see it, right? It's any number over 0 times what? 0 over any number, all right? We'll call it x, all right? So what's 0 over 0? Put it in a calculator. Who's got a calculator on them? Anybody got a calculator on them real quick? Just a regular calculator, not a phone. Put in 0 divided by 0, see what you get. Put it in. You didn't put it in. 0 divided by 0. Error. That's right. Okay, because y times 0 is 0. 0 times x is 0. Shh. I said no phones. I said no phones. Oh, he said you could. Even though I said you couldn't? Does that make sense? Why are you still talking to each other? I put you at the furthest ends of the room so you wouldn't talk, and you're still communicating to each other. So stop. Okay, next spot is outside that window right there, and outside that window. All right? That'll make it a little nicer. So look, what's 0 divided by 0? What do we say? It says error. All right, so that's really the only situation. Everybody listen. That's the only situation where if you multiply the slopes together, you're not going to get -1. Everybody see that? When you got a horizontal line and a vertical line. Every other situation, if you multiply the slopes, you get a -1. All right, enough of that. Let's do an example. That's what you guys came here for, right? Write these down. I'm gonna give you a series of 5 different points. This is the kind of stuff you're going to have to do. You're going to have to do this on a quiz. You're going to have to do this on a test. So I would pay attention. The least important thing is to say stupid things just to make people laugh. All right? It's not going to help you on a quiz. It's not going to help you on a test. So Logan, just so you know, I did kick somebody out yesterday. All right, so I'm on a roll. I haven't kicked anybody out yet today, so this is my last chance. So you're first on my list. All right, so they give you 5 points. Here's what the question says. Tell whether, and I'm going to give you like an A and a B here. Okay, tell whether the lines are parallel, perpendicular, or neither. So how in the world would I know if they're parallel to each other? And I'm not even going to graph them. Okay? I'm just going to look at the points. I'm going to do a little bit of math. And then after I do my math, I want to look at the 2 lines. I'll show you what I'm going to do in a second. I'm going to look at the 2 lines and I'm going to say, are those 2 lines parallel? So what would be in common if they're parallel? What would be true about them? They have the same what? Parallel. They'd have the same what? No, they're not equal to each other. They have the same what? They have, no, not the length. The length, they're lines. The same slope. They have the same slope. We just finished doing that like 10 minutes ago, okay? So if they're parallel to each other, they have the same slope. If they're perpendicular to each other, what's true about them if they're perpendicular? Not just opposites, but what's the word that I used? Look in your notes. It's right here. The slopes are what? Negative reciprocals. They're not just reciprocals. They're negative reciprocals, which means if one's positive, the other's negative. If one is negative, the other is positive. You could say opposite if you want, but I always like to say negative, right? Negative reciprocals of each other. All right? So that's what we're going to do. But let me show you what they give you. They give you line AB and CD. So what in the world are they doing? They're giving you line AB. How many points do you need to make a line? 2. All right? The minimum of 2 points to make a line. So if I want to find AB, there's point A, there's point B. What am I trying to do to line AB? I'm trying to find the what of line AB?
Slope.
The slope of it, that's right. Why do I want to find the slope of it? Because I want to find the slope of line CD as well. And then I compare the slopes. If the slopes are exactly the same, then the lines are parallel. If the slopes are negative reciprocals of each other, right, or if they multiply to be -1, you could do that too, then they're perpendicular. If neither one of those things are true, then you would say neither. All right, so let's see what we're going to do. So how do I find the slope if I know 2 lines? Well, you just did a homework on it last night, didn't you? All right, and so that's what we're going to do right now. We're going to find the slope of line AB. So I'll tell you what, I'm going to write it. Let's write it down. We got time. So -3, 4, and 3, 2. All right, so I want to find the slope between those 2 points. How do I find the slope? I'm going to write down the formula just so we can remember it. Remember, it's y2 minus y1 over x2 minus x1. You don't absolutely have to write that down every single time. I'm going to at least the first time so I can remember it. All right, so we subtract the y's from each other. And it doesn't matter what order. I put y2 minus y1, but it doesn't make any difference if I subtract 4 minus 2 or 2 minus 4. As long as you do what, though? As long as you subtract the x's, what? In the same order. Good, in the same order. So it doesn't matter how you subtract them. Let's just go the second one minus the first one. Is that okay with you? So it's 2 minus 4 over, and then we're going to subtract the x's in the same order. So if I went the second one minus the first one, I have to go what? 3 minus what? Negative 3. That's very important. A lot of people look at this and say, oh, it's just 3 minus 3. It's not. It's 3 minus negative 3 because this is a negative 3. Now let's do the work. 2 minus 4 is negative 2. 3 minus negative 3 is 6. So what's my slope? It's negative 1/3. Now, can I tell right now if the lines are parallel or perpendicular? No, I got to be able to compare the two slopes. So now I got to find the slope of CD. All right? So let's push this down. So let's find points C and D. Well, C is 1, negative 4, and D is negative 2, negative 3. So what do I want to do with those 2 points now? Find the slope of those 2 points, okay? And let's see what we get. So I'm not going to write the formula down again. I've already got it down. So subtract the y's from each other. Let's go the second one minus the first one, but again, it doesn't matter. So it's negative 3 minus negative 4. That goes on top, and the x's go on the bottom. So I'm going to go negative 2 minus 1. Let's work that thing out. Minus a negative is plus. That's a positive 1. Negative 2 minus 1. Add a line, change the sign. Remember that? Negative 3. So check it out. So the slope of AB is 1/3. The slope of CD is negative 1/3. And this one is negative 1/3. So what's true about these slopes? They're exactly the same. So what kind of lines are AB and CD? They're parallel to each other. And so I was able to figure out if they're parallel to each other without even graphing it. Did you have to graph these? No, you didn't. Okay, you did not have to graph them. All you did was find the slopes, and then what we know about slopes, we applied here. So if the slopes are equal to each other, then they're parallel. Does that make sense? All right, let's do one more, and then we're done with this section 3-4. It's taken us like a week to do this thing, it seems like. All right, and so now we're going to do part B. Let's change this color just to add a little bit of life to it. Let's do AE and BC. Tell you what, I'm going to give you, we got 5 minutes left. I'll give you 2 minutes. I'll give you 2 minutes. Okay? Shouldn't even take 2 minutes. Don't just guess. I want to see your slopes. All right? Listen, if all you do, just a second. If all you do is just guess and put parallel and you don't show me how they're parallel or why they're parallel, you're not going to get credit for it. Everybody hear me on that? On a quiz or a test, if all you do is guess, and like, look, I got a 1 in 3 chance. I'm just going to guess one of them. And if you guess correctly and you don't show me the slopes, you're not going to get it right. And you can't come crying to me and say, Mr. Hemrick, I put the right answer. How did I not get it right? Well, you didn't show me. All right, you got to show me how to do it. All right, you got about a minute left. I'll start you off. AE, so I'm just going to, not really doing the problem. All I'm doing is just rewriting A and E. Okay, so you find the slopes between these 2 points. Then you take BC. There's B, and there's C. And you find the slope between those 2 points. Once you get the slope of this one, and you got the slope of this one, compare them to each other, then make a decision. Are they parallel? Are they perpendicular? Or is neither of those things true? Basically just boils down to two slope problems, right? So you had them last night, but this is just one problem, and you got to find the slope twice. So it's really not much different at all from what you did last night. If you did it last night. I think most of you did. Did you guys get the slopes yet? All right, let's do this one. Slope is, remember, changing y over changing x, right? So you subtract the y's. Tell you what, just for fun, let's subtract them in the first one minus the second one this time. Let's just be a little different. So what do we write here? 4, well, why is my pen shaky now? 4 minus 3, whoops. Let's try this every day. I do that. And then let's do the x's, negative 3 minus 0. So we subtracted the y's, we put it on top, subtracted the x's, and we put it on the bottom. All right, let's figure out what that is. 4 minus 3 is 1 over negative 3. All right, so the slope is negative 1/3 again. All right, just like it was over here. So this line AE is also parallel to what? AB and CD. So if you were to graph them, you'll find out that this line AE is also parallel to these two. Yeah. No, remember I said this time I'm going to do it differently. I said I'm going to go to the first one minus the second one. Okay, rewind it. I said it. All right, it doesn't make any difference. It would work the same way, wouldn't it? If you did it the other way. Watch, 3 minus 4 is what? Negative 1. What's 0 minus negative 3? Minus a negative. That's a positive 3. You still get it the same exact thing, don't you? It doesn't matter what order you subtract them. As long as you subtract the x's and the y's in the same order, make sure you do that. All right, let's do this one. Again, let's go the first one minus the second one, just to be different, that's all. Okay, so it's 2. Is it 2 minus 4? No, it's 2 minus what? Negative 4. And then it's what? 3 minus 1. Let's see what that is. Minus negative is plus, that's a 6. This is over 2. Always reduce it. It's a 3. So look at this slope, and look at, I'll put this over 1. Look at that slope. First of all, are they parallel to each other? No, they're not. So now we have to decide, are they perpendicular? How do I know if they're perpendicular or not? Are they negative reciprocals of each other? Well, this one's negative, that one's positive. That's a good start, right? This one's 1 over 3. This is what? 3 over 1. Are they reciprocals? Are they opposite or negative reciprocals? Yes. So what are they then? They're perpendicular. All right.
Varsity soccer, you have a dismissal time of now. Thank you.
All right, everybody good? No, he told me earlier he had to leave at 1:45, but I probably should have waited till they announced it, but that's okay. All right, so what do we have? 23 to 36, is that what I gave you? Okay. Because I don't have the paper in front of me. Is it 23 to 36? Okay. So 23 to 36. What are we calling this? 3, 4, C, is that right? D, is it D? Did we turn, oh yeah, we did A, B, and C. So this is D, 3, 4, D. All right, there it is.